Okay, so now let's solve the problems. So I have these values summarized here. The 20 Newton is the weight, the 50 meter is the height, how it have traveled from the initial point from the ground up to somewhere in the air, that 20 meter, and the V at that point is this one. So as we have analyzed, this is the logic of how we should work. At first we will, from the weight, we find the work of it, and then we find the change in the kinetic energy, and then from that we can find the initial kinetic energy, and then we can find the initial speed that they ask here. So let's solve one by one for the work. Here, as we have analyzed before, there's only one work act on the rock when it's moving. So let's say this is the free body diagram and just the point mass represent for the whole rock. Then we just see that that should be the gravity that pull it down. That's the weight, which equal to mg. Okay. Oh yeah, and as we will need the g's, the m here for the kinetic energy, so let's find the weight as well. So let's find the mass as well. So here we got the weight equals to mg. So if we solve for m, that m will equals to the weight divided by g, which is equal to 20 newton divided by 9.8 meter per second squared. And that should be, how much is that one? Okay, let me see. Yeah, we can use a calculator. Let me use a calculator here. So I got it about 2 kilograms. Okay, and I will just take two significant figure. So I will just got 2 kilograms here. Okay, because we know that 1 Newton is actually from the second Newton's law, F equals ma, so the unit of F is a Newton, the unit of mass is that a kilograms, the unit of acceleration is meter per second. So you can see that 1 newtons will be 1 kilogram times with meter per second square. So if we got the units here, meter per second square, this is Newton, then the mass should be kilogram. So okay, so we got the mass. Let's just leave it there. Then we can use later for the kinetic energies here. Now let's get back to the work. Maybe I will move everything down a little bit then. Okay, next is the work. The work done by gravity. We got the gravity already. And what is the displacement? How is travel? It travel upward, right? Right? So actually, if I draw the displacement, how do I say, like precisely based on this diagram, then it should go from the initial position, this point here, up to the final position. So it should be something like this. It go like this. Okay, this is the whole displacement S. Okay, yeah, but we just need to care about its direction, right? So I just simplify it by draw another similar one, but the direction is still the same. Then I can apply on the free body diagrams here. Just on the point mass here, just because I need to identify the angle, right? Yeah, the angle between the force and the displacement. So now you can see that the angle once again is defined from the displacement vector to the force vector. You see that? So can you tell what is the angle of this one? Yep, that will be 180 degrees, right? Because both of them are opposite to each other. So the work here, the work by the gravity, I will just put it like mg, okay? That would be the weight, the weight times with cosine of that 180 times with the displacement s. Okay, now we got the equation. Okay, just start with the equation. Now plug in the values. So we plug in the values here. The weight is 20 newtons cosine of 180 is -1, and distance here, I mean the displacement, the magnitude of it is actually the distance here that having travel. That could be 50 meters, right? Okay, and now what do we have here? Well, we'll got 20 times with 15 to be minus 300 joule. So actually 1 newtons times with 1 meters is 1 joule. Okay, this is like the nature of the work, the nature unit of the work, but we know that work equivalent to energy, so that's why we have it in joule. Okay, and you see here we have this one as a minus sign here, you see that, which it indicates that weight does not help when it moves upward. It's actually try to like against it, so actually the weight reducing the energy of the object, of the rock. Okay, so now let's go to the work kinetic theorem, and now we just need to like copy and paste this one here to move it here. So let's just rewrite it again. The work energy theorem is said that the work total equals to the change in the kinetic energy. Change here represent for this one, I go to this delta. Okay, we call this one as delta. If you want to read it, it's a Greek letter delta. It's a Greek letter delta. Okay, so this is delta will equals to final kinetic energy minus initial kinetic energy. And okay, so now we need to find the final. Then we can solve for this one. So kinetic final will be 1/2 of the mass v squared minus 1/2 of the mass u squared, which equals to the work that done by the mg's here. Okay, so we can either like start to plug in the values up to this point, or usually I would recommend you to like try to like rearrange them as how do I say, like as like in simple like this first, and then you can just plug in the value numbers at the final stage. But it's up to you, okay? Whatever that can make it easier for you. Let's say that if you want to like rearrange to solve for you, then how can you solve for you? I could say that you have the weight, the total work, the total work will be okay, I see this one as a minus here. Okay, so I think that oh yeah, let me show you how to. Okay, so I want to move this part to the other side to make it as a positive, so we copy it and move it to the other side of this one like this, right? I will move it to the left one, but I also want to move this one to the right one, so we move it here. So then the minus become plus here when we move to the downside, and the plus here become the minus here when you switch the side, right? And I will keep the final one the same on the same side. Make sense, right? Okay, now we want to solve for u, so we will need both sides. We need to move this part here to the other side, and because this is a multiplications, right? So if we want to move it to the other side, then we need to divide it, right? So then it's going to be equals to this whole thing's here. Let me just copy it again and paste this here, right? Divided by this one, because we just moved that factor to the other side. Make sense, right? Okay, and now we have the u will be just the square root of this whole thing, right? Copy and then paste this here. Okay, like this. Okay, let me try to. Okay, so I would say that I highly recommend this one. Try to solve for the variable before plug in the values, and then later you just need to plug in the values to calculate for this one, right? But I would say that